Now to number 8 out of 11. So we've got 3 more to go, but these are going to be really quick. I'm probably going to want to get this done in 10 minutes. Consider the power series, the alternating power series, -1 to the n, x to the third to the n, x over 3 to the n. Using the appropriate test to find the radius of convergence and the interval of convergence. Because these are both to the power of n, it doesn't matter if there's a -1 here. You could or could not do alternating series tests, but the simpler thing for me to do is to do the ratio test, which, if you're not familiar with the ratio test, an, where we have an set as our the term inside our series, and the ratio test requires us to compute the formula an plus 1 over an, which changes this into -1 n plus 1 x over 3 n plus 1 So if we could also take this 3 down here and leave this x up here, times, and invert what we have here just so we could divide it. -1 to the n, x to the n, 3 to the n. Expand this equation. -1 times -1 to the n times x to the n times 3 to the n over 3 times 3 to the n times -1 to the n times x to the n. Cancel out like terms. Then you're left with the absolute value of -x over 3, which by the ratio test is less than 1. And the values of x on the interval of convergence that allow that to happen are any values in between -3 and 3 as your interval of convergence. But saying the absolute value of 3 is the same thing as saying 3 under the absolute value of -x is less than 1. So the radius of convergence ends up being 3 because the absolute value of -x is going to be bordering, if not less than 3. That problem's done. Going to number 9.